We are continuing our discussion on logarithms in this lesson. So on your master formula sheet or on your note sheet, you have a whole bunch of rules for exponents and some examples of them. So one of them is a product property. I just want you to remember that when you are multiplying two logs together, you can also split them up and do the logs of them each separately and then add that together. When you're dividing logs, you can subtract them. And then when you're raising them to a power, you can bring that exponent out in front. All right, so here we go. We're going to just simplify these first of all. That is our goal here. What happens is I have given you kind of the right side of that property on these, and you're going to give me the left side. So when I have two logs added together, I can smush them together into one log. Notice I have to have the same base, which I do right here. It's base 5. But when there's an addition sign in between, then I can take these two things and I can multiply them. So in here would be x times 4, which of course is 4x. Okay. When there's a subtraction sign in between here, I can divide. So I will have log base 3, and again, they have to have the same base, of 21 divided by 3, which of course is log base 3 of 7. And then here, of course, the exponent can come out in front, and this becomes x of log base 9 of 4. Okay, so just some quick reminders of those properties. Then, of course, there's the equality property, which makes sense. The only way that these two would be equal would be if 2x were to equal 30, and then x would have to be 15. All right, we are going to use some of those properties to solve for some different variables now. Okay, so in this first one, again, I have an addition sign in between, so I can take those two things and I can smush them together into one log where I'm multiplying x times 4 right here. And of course, x times 4 is 4x, so that's what I have right here. And then I have log base 5 of 17. And then, of course, the only way these two sides of the equation are going to be equal is if this is equal to this. So, of course, 4x equals 17, and x has to be 17/4. I always want you to plug this in and remember that neither your base or what's here can be negative. Okay, and of course, it's not here, so we're good. All right. And then this one, of course, I am subtracting. And so I can make that into one log where I divide. So I would divide 21 by 3, and of course I would get 7 there. And then I would have log base 3 of t. Again, the only two ways that these are going to be equal is if my quantities here that I'm taking the logs of are equal. So of course 7 has to equal t, which it does, but again, I want you to plug it back in and make sure that neither your base nor what you're taking the log of can be negative. All right, on the next one then. Again, I have subtraction in here in the middle, so I can take this quantity right here with this quantity and divide them. So I will have log base 3 of 32 divided by 4, which is 8. Over here, I can take this and I can bring it back on top and make that a power. So then I would have log base 3 of x squared. And of course, the only way that this would work is if these two quantities are equal, 8 and x squared. And then, of course, to solve for x, you would have to take the square root. And when you take the square root, you need a plus or minus. Okay. And of course, this breaks down to either positive or negative 2 root 2. But be careful, because what you're taking the exponent, or what you're taking the log of, can't be negative. But when you do that, even though you would plug in negative 2 root 2 right here, this 2 would come up here, and when you take negative 2 root 2 and you square it, it's going to become positive 2 root 2. So this one can be either negative or positive. Okay? So this one's okay. All right, then there's some specific logs that we need to talk about called common logs. If no base is written, it's considered to be a common log, and a common log is nothing more than a log that's in base 10. It is the button on your calculator that the log button on your calculator is logs in base 10. Okay, and we will use your calculators here in a minute, so I'm going to get this linked up. But log base 10 is what is the calculator button for this. Okay, so if I ask you to kind of simplify this, I'm just going to show you, and you'll figure out some shortcuts here, but I'm going to kind of show you the long way until you get that, and so you can assume some things on your own in a minute. But if there's no base written, it is assumed to be log base 10. Okay, so if I want to figure out what x is, then it would be easy to change this now from logarithmic form to exponential form. Okay, so I can switch this from a base of 10, an exponent of 2, and of course it would equal 4x. Well, we all know that 10 squared is 100, and so then x is 25. And when you plug it back in, you have a positive base and you have a positive number you're taking the log of. So that's all legal and good. Okay. On the next one, again, this is base 10, so this means 10 to the 4x equals 17. That is not doing me any good right now because I can't get 10 and 17 written as common bases, so that is not going to work. So didn't help me a whole lot. So now what I'm going to do is I'm going to take the log of both sides. So when I put a log in front like this, when you can't get common bases, then you take the log of both sides. So that's what I have right there. And then you can kind of use your properties. 4x will come out here, so I will have 4x times log of 10 equals log of 17. And again, these are both in base 10 right now, which is good. I want to solve for x, so I want to divide by log of 10. And then that's what 4x equals. And of course I want to solve for x, and so then I want to divide by 4 there. And you can stick this all into your calculator. So I will stick this in as log of 17 divided by log of 10, that quantity, divided by 4. So I'm going to go to my calculator, and it's best if you don't round. It's best if you leave this all in here and kind of do it all in one step. So log of 17, I'm going to just push this on your calculator so that you can see what I'm doing here. Log of, let's see, I'm going to clear this out. We'll start over. Log of 17, close that, divided by log of 10. Close that. You can press equals if you want, but then I need to divide that quantity by 4. And then x comes out to be about 1.2, or no, about 0.308. Okay? X comes out to be about 308. Okay, and again, I want you to make sure that when you plug it back in, you're not causing a negative number to happen, and you're okay right here. So, you're good. All right. On to the next one. It's in logarithmic form right now. This kind of gives you an idea of how to do a change of base formula. So if I want to do a change of base, then I can change log base 5 of 16 to log base 10 of 16 divided by log base 10 of 5. And then again, when things are in base 10 down here, that's when you can use your calculator. You don't even need that 10 written, but you can take log 16 divided by log 5, and that will help you evaluate that quantity. Okay, so this is the change in base formula. And we've got that all good to go right there. All right, so right here, if I want to do this formula and not have to write it in exponential form, again, I would use the change of base formula, would be the easiest way to do this. And then to do that, I would take log of this number right here, which happens to be 9, divided by log of this number right here, which is 2. And again, these technically are base 10s, but you don't need the 10 written. And then you can go right to your calculator, and you can type in log of 9. I'll just make sure you know how to do this. Log of 9 divided by log of 2. And you should get 3.17 about. Okay? All right. Okay, similarly, I have two things. I cannot get them in common bases, so I am going to take the log of both sides now. So I will take log of that, and I will take log of this. Of course, I can take this 2x and bring it out in front. So I have 2x times the log of 3 equals the log of 11. Divide by log 3. And of course, that's what 2x equals. And then I have to divide all of that by 2. Okay, so I'm going to take log 11 divided by log 3, divide that answer by 2, and x should come out to be 2.183, about. Okay, you're rounding here, so that's what's going to happen. All right, on the next one, again, I can't get 4 and 9 written as common bases, so I am going to take the log of both sides. And so when I take the log of this and the log of this, then of course you need to know what happens is that this will come in front and this will come in front. So I will have 2x squared log 4 equals 4x log 9. Okay? Then I am going to divide both sides by log 4. And I will get 2x squared equals, you're going to need to put this quantity on your calculator. And when you do that, you should get about 1.585. And I'm having to round here, which is not perfect, but I don't really have a choice. Okay? And so then when I multiply that 1.585 times 4, so I'm multiplying 4 times this times x, I will get about 6.34x. And then of course what I need to do is I need to be able to solve for x. So I am going to move this to the other side so that I have 2x squared minus 6.34x equals 0. Then I can factor out an x, and then I will have 2x minus 6.34 equals 0. So right here I get x equals 0. And right here, of course, I get 2x equals 6.34, or x is about 3.17. Okay? And you want to make sure that when you plug those in, you're not having negative numbers in there, which you don't. So 0 and 3.7 both work. Okay? I could take a quantity to the 0 power, and I am okay. All right, last one, I believe. Again, I can't get these in common bases, so I am going to put a log in front of both of those. And then this 5x has to come out in front. I probably don't even really need to do this problem, but I will do it quick. I'm going to do it really super fast. So I have 5x times log of 3 equals log of 13. And of course 5x equals log of 13 divided by log of 3. And then of course to solve for x I need to divide that by 5 yet. So I'm going to divide that whole quantity by 5. Okay? And when I do that, x comes out to be about 0.467. Alright, then you guys, I'm going to just talk about one more that might not be on your note sheet. I don't know if it is or not, I don't remember, but I do want to talk about it. And that is something similar to this, except for I want this to be a 1 in here instead of a 2. Okay? So I'm going to make that be a 1. All right, so here we go. If I put these, right now it's in logarithmic form. Okay? If I put them in exponential form, then this is what I have. This is my base, so that's x minus 1. This is my exponent to the negative 2 power. And of course, this is what it's equal to, is 4. Okay? First of all, when you have a negative exponent, you need to remember your exponent rules. Negative exponent means that it goes 1 over that. And then a super common mistake people will make is they'll square the x and they'll square the negative 1, and they will do it that way. But remember, when you take a quantity squared, it means x minus 1 times x minus 1. So what I have is 1 over, and when you FOIL that out, you're going to get x squared minus x makes negative 2x, and then negative 1 times negative 1 makes positive 1. Okay? Personally, I don't like to deal with fractions, so I am going to multiply both sides by x squared minus 2x plus 1. And then that will get rid of my denominator here. Okay. And then if I distribute that 4 through, I will have 4x squared minus 8x plus 3 plus 4. Sorry, I'm a step ahead of myself. Okay, and then of course I will subtract 1. So I will have this. And then I can factor that quantity. And when I factor that, I will have 2x and 2x and 1 and 3, and they both need to be negative. So here I will have x equals 1/2, and here I will have x equals 3/2. Okay? But again, I want you to plug those back into the original equation. When you plug in 1/2, I want you to notice what happens way the heck up here. When I plug in 1/2 right here, I have 1/2 minus 1. And your base, when you're doing logs, can't be a negative number. So when you plug in the 1/2, that gives you a negative base, which is not okay. So this one actually doesn't check and it doesn't work. When you plug in 1/2 and you do 1/2 minus 1, that's okay. This one plugs in, it checks, it works. Okay, so that one works and it is fine. But the negative 1/2 does not. All right, that'll do it for us.